I would like to open the discussion. Imagine you are in a dinner situation and Tine invited you over to Pipistrel to talk about the technologies. So what would you like to ask? Or let's start at the very, very first thing. I saw a lot of people taking pictures from your presentation as you invited them. Would you mind to share the presentation?
We can discuss, yeah, I think it could be.
Okay, so send it to me and I won't send it to everyone who sends an email to me. Sounds good? Sounds good. So that's not shared from you. Good. And imagine, what would be your first question to Tine if you have a dinner conversation on that?
What would be my first question?
Or Jamie? Can switch on here. Yes.
What would be my first question? It's difficult to say because it's very much into what we're working and the things, See, the only thing I would ask is that little model, about C1, C2, C3, how robust is that little model?
So, P concept is the software combination that is running these visualizations. It has many components, right? Your sizing, your volumes, your structural definition, mass estimations, and all that. So, University of Delft and Politecnico di Milano did a ton of wind tunnel validations, as well as they contributed their own historic validations on the structure side. But obviously, when it comes to assumptions, in particular related to hydrogen building blocks, this is a moving target, right? So let's say how good or not as good your hydrogen storage tank might be. There's a lot happening now, from vacuum insulated tanks, foam insulated tanks, aluminum composite, type 4, type 5. We just continue to populate this database. And this is why I continue to speak about snapshots in time, right? Because with the knowledge and information that we were equipped back then, yeah, we could stand behind that idea holds water. But obviously, as we move along, things change. And say, if I was challenged with the same question that you posed to Sean, I'd be most interesting what was the most unexpected learning. So what you wish you knew 3 years ago that you know now, and obviously if you don't want to share in front of everyone, that's totally fine.
Well, we are just between us, so.
But I think fundamentally, every time something gets built, and it doesn't matter what it is, a battery, an aeroplane, a hydrogen-powered engine, a tank, a hybrid aeroplane, right? Whatever it is, the whole world advances because all of a sudden it's possible, and the knowledge has been verified and de-risked, right? Immediately, like literally overnight, there's no more mystique whether the assumptions were right or wrong.
But that's an amazing
demonstrating and doing things is truly the essence of development.
It's a good question. So what do you learn? What do you want to know before, but what we know now?
Well, after 3 years and a half of flying this hybrid aircraft, it's 600 kilowatts, so it's not a small bird. You'll see it coming this weekend. What I would have loved to see better is still the fact that batteries are a long ways to go, to give their full potential. And that's what worries me the most. Right? And
so this spectrum density is
I'm totally with Tina when we say don't make an electric aircraft only for the sake of making stuff electric, only for showing people CO2.
But did you ever thought about the energy capacity of a battery is an issue? Well, everything is about range and weight. Okay, but if you think twice, then the energy itself is weightless. It is just the storage. So the energy, full or empty, is the same weight. It's just
which is bad.
Which is bad.
Which is exactly bad.
But if you think about it's just the energy storage, like the battery itself, but the charge on it, the electricity, the energy is weightless.
Yeah, but it's still, for an airplane, you know, I mean, a car, it's a rolling resistance, okay? For an airplane, it's gravity, okay? And who is the enemy of, in aviation, is the gravity. So if you got something that, you know, doesn't lose weight with sign, and you discharge it, it's a penalty. And unfortunately, today, we hear a lot of, you know, when I was at GM, I was laughing. I was in charge also of lithium polymer batteries at the time, many years ago, in the previous life. And we had to say, you know, we say that in automotive, you know, there is engineers that are liars, and then there's battery engineers. Because, you know, the battery guys had always a tendency to promise you that they could do a lot more better, much better, you know, than what time can do to you. There was an excellent article from the guy from Cooper, you know, that was, I know the guy is from Stanford, you know, a Chinese guy, very bright. And he said, you know, even with our best batteries and what's going to happen, think about 20 years from now to get, you know, 50 to 80% better batteries than what you have today, okay? 20 years, okay? This is the first time I heard somebody that is, you know, gives you some realism into this thing. So you have to leave what you have, okay?
So what is the magical number of weight to kilogram? So the battery watt hours to kilogram. So at this 500 is the magical number for small aircrafts, for 4 hours of range, 4 seats.
Or even more than that.
Or even more.
Now you start to.
So 500.
Now you start talking.
Okay, now we start talking.
At less than that, yeah. I mean.
So you heard about the recent announcement from Cattle with the 500 watt hours per kilogram battery on cell level?
As I said, you have plenty of guys that you have liars, and then you have battery engineers. So you can hear many things, you know, and then I'm talking about reality. I'm talking about at system level, okay? Integrated, okay? And there is no magical there, okay? This stuff comes from China, most of it, okay? And then it's put together with people, smart people like Tine, like, you know, people I have in my teams. But at the end of the day, 100 per kilo, it's 10% more or less. We're in the same range, okay? So there is no miracle here, no free lunch. You have to do what you have. Sorry, too long.
Jamie, do you want to add something? Quick question. A quick question starts with the introduction of your name and the question mark at the end.
And if you have a battery at $500 per kilo, I buy it immediately.
Name is Chen. I work for Aerospace GmbH. We locate in Stuttgart area. Just a quick question in terms of understanding the energy density you're talking about. Are you talking about the cell level or are you talking about the package level?
I'm talking only system. I don't care about cells. You can have the best cell you want. I'm talking when it's integrated in a power pack, in a battery, and it's functional. That's what I'm interested on.
Thank you. That's all I need to know, and that's actually, yeah, important.
That's what flies.
Thank you.
Bottom cells, they don't fly. They are in the labs, you know.
If I'm on my feet, any other questions to grill these experts?
Hi, Ken Sports, Vertical Flight Society. When it comes to flight training, I'm wondering, how do you see that market evolving? Will it be incremental? Will it be large fleet-wise? Will it be led by certain countries where, say, the cost of operation are higher in flight training and the adoption of training aircraft?
Leave it to the experts. I'm commercial. I want to do commercial. It's doing training.
So, if you look at the whole pilot training industry, so this is an industry that absolutely depends on dispatchability and robustness of the aircraft that they use. So having certainty is that you can fly when you want to fly, right? And it's not that when you turn the key, there's 3 error messages and 6 lines that you don't understand. That's a nightmare for these operators. So it is almost obvious that they will never be first and widespread adopters. I'm talking about the very large flight schools, right? But slowly and surely, they will get there because the advantages are such that you cannot disregard them. There's the cost, there's the absence of noise. These operators often suffer many complaints by their neighbors. There's also bans showing up in different parts of the world about curbing pilot training activity because it's annoying. It's repeatable, wow, 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 all the time. Not that electric aircraft are absolutely silent, but 10 decibels of the difference helps tremendously. And these operators also go through a lot of what they call rotatables. They almost think of an engine as something that's disposable every 2,000 hours. They don't have time to overhaul, they swap. And when you have an aircraft that has a relatively modular propulsion system, where each of the modules also happens to be upgradable, right, then their rationale behind the purchase is just different. It's different to justify this. Now, there are very different patterns that large flight schools use across the world. And for some of them, 1 hour endurance just doesn't cut it. Right? So, the endurance of any aircraft is a very elusive thing until you come to the Airbus A350 that can fly any point to any point and there's no more discussion. Right? But below that, everybody has an interpretation of what's goodness for them. So you basically, as an OEM, you have two approaches, really. One is to be convincing, meaning you have to start convincing your customer that they also could start teaching in different ways, which basically tells them that they are wrong in how they have been doing the thing for decades, right? It's a very uncomfortable discussion to be had. Or you start figuring out ways in how you approach the quickest possible their desire when it comes to the practicality of the plane, maybe linked to endurance or speed or what have you. And CATL, yeah, 500 is a good number. Sell or pack, it's a very good number. I would ask you to respond to your emails more frequently so that we can get these batteries in our planes as well. So we, the integrators, need you as the source of technology to work with us, right? This is not a buyer-supplier relationship that will unlock success. It has to be a collaboration, and everybody needs to assume a bit of risk going in. Right?
From Veli's generation 1 to 2, what was the difference in batteries? So lifetime, cycles, you mentioned cycles, 200
The
hours?
difference in endurance was minus 1 minute.
Well,
It actually became less, but they charge twice as fast and they last 4 times as long. So the main effect was in the economics. Right?
Yeah.
If you look at the flight school, it matters a lot how many students they can rotate through during the day. And daylight, not 24 hours, right? So it very much matters how quickly you can charge and bring in the next student.
so it's now 40 kilowatt hours, 40 kilowatts charging, a little bit? So this is roughly 35 minutes charge for roughly 1 hour flight.
Pretty much.
And you have 4 times more cycles. So aircrafts get better as older they are.
Like wine.
Like wine. Okay. Any questions from the audience? I will come back to you because you had just a question.
Thank you. I'm Adrian Norris from Altitude Consulting. 2 really short questions. You gave a target number for the energy density for batteries. Do you have a target for power density and discharge rate? And the second question is about the storage of liquid hydrogen. In the 19-seat aircraft, you have a large liquid hydrogen tank in the fuselage behind passengers. What are the safety and certification issues with that?
Like I said, in the era of storage of hydrogen liquid, you have to work with people that have good knowledge, because what you just said is a key issue. It's clearly a key issue. And the beauty of hydrogen, though, is that the molecule is very fast to disappear in the air. So if you master that the right way, you shouldn't have this kind of problem, okay? The story of the Zeppelin, it's more in the city of, where it was built, it was not the hydrogen that was the problem. It was the fact that the gearbox provided a spike into. But if it were for the hydrogen itself, it would have been, it's very fast to go. So you have to put all the safety that goes with it, and its accumulation of knowledge, like Jean was saying, how you store it, in the way. I don't see our issue, our source of, energy other than liquid for an airplane, to be honest with you. So it's difficult. I'm not gonna, lie to you. It's difficult, but you have to make sure that you vent it as much as you can, because otherwise, obviously it's a bomb. People made that hydrogen bombs, right? So, but even a tank of gasoline in an airplane is a bomb, right? We have seen that a while ago. So
I'm happy to add a few things, if I may. You mentioned the Hindenburg, and I mean, most of the flames you see there is actually not hydrogen burning, because you can't see it anyway. It's the resin from the fabric, but yet it creates this incredibly emotional response with many people, and it starts to drive acceptance backwards, right? Which is bad. So we as the community should be more factual, like John just was, right? In explaining what might happen and what not. On the topic of tanks, aviation is not scared of flying or lack of safety. Mostly we are scared about sudden stoppage, right? When gravity hits in an impulse. There are ongoing activities here in Europe with the Dutch Aerospace Center leading the way, Airbus as well. We are participating a small amount. That for the first time consider a notion that is very foreign in aviation. And this is, can you do things to improve safety before you hit the ground? Like venting, perhaps calling for help in a different way. Project is called Albatros. If you have seen the Albatros bird land, you'll see that they're not very good at landing, right? They tumble. So the project carries the right name. I do encourage you to look at a few of their proceedings because they are fascinating. The placement of the tank, and I think Kawasaki can chime in because motorsports has started to use hydrogen in a less visible way, right? But also, because of these wanderings, for the first time in aviation, we are again departing from something very established when it comes to structures. For the longest time, structural people desired structures to be rigid or stiff, hard. Now all of a sudden they want them to be soft, right? To absorb, to cushion. So there is also a paradigm shift in how you go about there. So there is so much knowledge because hydrogen carriage on board aircraft is being discussed that could benefit passenger safety for, let's say, crash worthiness. So seats, right? Have you noticed how your seat is bolted to the floor of your airliner? It's big bolts. There's nothing soft about it. So maybe there's a direct opportunity for knowledge transfer when it comes to that as well. But the particular placement in the concept that I showed is actually in the wing box, and the tank is suspended in a non-rigid way. So think of an egg inside the frame.
But I would love to give Jamie a little bit more room here. So anything, thoughts from your side, anything you would like to add?
Well, I think since you mentioned about Kawasaki's involvement in the hydrogen on the power sports side, yes, I talked about this research body which we formed last year. January of this year, the team participated in a rally in Dakar, and I think that was like 6, 7, 8 days. I forgot the exact days, but we completed that. And that was powered by our motorcycle engine and ran by full liquid hydrogen. So, and what's nice about this activity, which is what we are getting involved, is we are the, let's say, the car or the motorcycle manufacturer, and the activity is also inviting all the major suppliers in Japan. And I think you brought about the fuel tank, and it is a challenging task, but it's nice to have the entire industry from tier 1, tier 2, everybody is starting to pay attention and people are starting to participate, at least back in Japan. So I can only see this growing and continue to keep more attention back in Japan. So we're very, very fortunate and we enjoy the ride.
And one thing sticks into my head, what Tina said. So since 2018, no new development without electric or at least hybrid propulsion system on the roadmap. Is there any similar on your side at Kawasaki? Is there any? Well, I think it's a bold statement. So there's no development from 2018, and it's 6 years from now, without electric or even, or at least hybrid propulsion.
Well, our strategy is, we call it a multi-pathway. So let's not get stuck in a single pathway. Just try to keep the options open as much as possible, because I mean, every market, every country is different, how they generate their energy, electricity, and you just can't copy paste and one single strategy to a different country. So to answer the question, we haven't really locked ourselves into a single direction. We heavily invest ourselves in developing engine, the next generation engine. We love the engine. Of course, we continue to make the engine better, but also we keep an eye on other technology. So electric, hybrid, hydrogen, so we just continue to do that.
First electric motorbike from your company when?
Actually, we have launched, so if you go on the website of Kawasaki, we have actually launched our first generation full sports electric motorcycle, and also the first generation strong hybrid motorcycle as well.
Okay, so electric motorcycle range?
The range is, what was that? That is more commuter type, so, sorry, I put the number here. But, yeah.
Range is everything in electric propulsion. Okay, due to time, we are very good in time, so one question, of course.
Willy Kacke organized eFlight Expo here since the beginning at the AERO. I have one question on Jamie as well. What about, there are several eVTOL manufacturers in Japan, also aviation manufacturers, as we look at Honda. Are there other manufacturers going down this road whom you're partnering from home? Especially on the eVTOL side, because they need even more energy. So batteries is even less sufficient for them.
Well, yes, I know where you're coming from, and many of the automotive manufacturers, well-known companies, have got involved with that side of the business. Have we been approached by somebody? I can't name the company, but maybe yes. I mean, and what is Kawasaki going to do? I can't answer the question right now, but at least the good thing from our view is that people are, let's say, realizing once again the benefit, the good side of the engine. What can be done? What are the benefits? I mean, the technology has been around for many, many years. There are so many, at least from our view, great benefits of what the engine can provide, and going forward by merging with another technology, it's just going to continue to open up more opportunity for us, and also which is going to be good for the future as well.
Okay. Well, thanks so much. Due to time, I would like to close up this panel. Thank you so much, Jamie, Jan, and Tine. Thank you so much for all your questions.
Beautiful.